Okay, so we're going to start with absolute value equations today. And that first means we're going to define absolute value, which is the distance between that number and the origin, or 0, on the number line. Or another way that we think of this is the positive value of what is inside the absolute value bars. And so we're going to talk today about how to solve an absolute value equation. And let me just put a very simple one out there. And that is this. The absolute value of x equals 2.
What? How?
All right? No, it's just an equation. So the absolute value of x equals 2. The question is, when we go to solve this, what is x? 2 or negative 2. It has two possible answers because the absolute value of 2 is 2 and the absolute value of negative 2 is 2. So what this means is that x equals 2 or x equals negative 2. So we have two possible answers for this. All right, let's try one that's maybe a little bit more complicated. So let's do this. Absolute value of x plus 1 equals 5. Can you see what x could be? 4. 4 will work. So 4 plus 1 is 5, and the absolute value of 5 is 5. So x can equal 4. Can you see another number that will work in here? Negative 4 will not work because negative 4 plus 1 is negative 3, and the absolute value of negative 3 is not 5. Negative 6. Because negative 6 plus 1 is negative 5, and the absolute value of negative 5 is 5. So this, again, shows us that we have two solutions to an absolute value equation. But that's just if it equals a positive number. So let's look at something for a minute. What if absolute value of x, let's make it this way, plus 2 equals 0. What can x be? What would work in there? Negative 2. Can you think of anything else?
No.
No, there isn't anything else. There's only one thing that it can be. And this is important because this is going to set up for us some rules that we're going to be using. But let me ask you this. What if I have the absolute value of, how about this? X minus 1 equals negative 3. Can you think of anything that x would be?
Nope.
Why can't you think of anything that x could be?
Because unless there's a negative sign on the outside of the absolute value, like if it's negative on the inside, it's going to come out positive. So
Exactly. When you take the absolute value of this, it's going to come out positive. It can't come out negative. So guess what? This particular equation has no solution. And this sets up a general rule for us. And that general rule is this. If we have an absolute value equation where the absolute value of something or other equals a positive number, we're going to have two solutions. Okay? If absolute value of something equals 0, we're going to have one solution. And if absolute value equals a negative number, we're going to have no solutions. And I want to bring out something that I gave you the other day, and that was this. It's a chart. And it has those three different types of equations on it. So if we have absolute value equals a positive number, we will have two solutions. If we have absolute value equals 0, we will have one solution. And if we have absolute value equals a negative number, we will have no solution. All right? Now, let's talk about when there's a solution, how do we find it? Okay? And let's go back to our example. In our example, when we were trying to find our two solutions, what we were thinking of here is what will make this x plus 1 equal to 5 or equal to negative 5. That's what we were thinking. So that's actually how we're going to set this up. So let me do a more complex example from the bottom of the page. And these are worked for you already. We're going to do absolute value of 2x plus 5 equals 3. Now, this is harder to look at and go, oh, here's what x is. We're going to have to actually calculate it. But here's what we know. If this absolute value equals 3, then what is inside here either has to equal positive 3 or negative 3. Those are our two equations without absolute value bars. 2x plus 5 either equals 3 or 2x plus 5 equals negative 3. Those are my two equations that I'm going to set up to figure out my two answers. And of course, I'm going to subtract 5 from both sides and then divide both sides by 2. And I'm going to get either x equals negative 1 or x equals negative 4. Those are my two solutions. Now, my second example here is absolute value equals 0. In this case, there's only one solution, and that solution is wherever what's inside here, so that is 2x plus 5 without the absolute value bars equals 0. And we're going to solve that by subtracting 5, dividing by 2, and we get x equals negative 5 halves. And then finally, at the very bottom, we have an example. Absolute value of 2x plus 5 equals negative 2. And we don't have to calculate anything here. Absolute value is never going to be negative. It's always positive. So it can't equal a negative 2. No calculation necessary. My solution is simply no solution. All right? So let's go ahead and turn the page, and we're going to do some examples together. All right. First of all, we have A, absolute value of n equals 2. So first of all, ask yourself, all right, is this absolute value equals a positive, 0, or negative? And it's positive. So it's going to have two solutions. And the two solutions are you take this, set it equal to 2, and set it equal to negative 2. And in this case, there's nothing to solve. Either n equals 2 or n equals negative 2. If we go to B, we have absolute value equals a positive number. It's going to have two solutions. The way we find that is we're going to say k plus 3 either has to equal 4 or k plus 3 equals negative 4. All right? That what's inside there either has to equal positive 4 or negative 4. And when we take the absolute value of it, it comes out to be positive 4. So now we're going to solve both of these equations. So subtract 3 from both sides, and we get k equals 1, or subtract 3 from both sides here, we get k equals negative 7. Now, let's go to C. And C may seem confusing because there's all these negatives. It does not matter. All we're looking for is absolute value equals, and it happens to be a positive number. If absolute value equals a positive number, we have two solutions. The way we find those is that what's inside of our absolute value bars either equals 10 or negative 10. So we're going to set up two equations. Negative t minus 3 equals 10, or negative t minus 3 equals negative 10. And we're going to solve both of those. So add 3 to both sides. And I have negative t equals 13. Divide both sides by negative 1. And I have t equals negative 13. So let me get my second solution. Add 3 to both sides. And I have negative t equals negative 7. Divide both sides by negative 1. And I get t equals positive 7. So t is negative 13 or t is positive 7. If we look at D, I've got absolute value equals 0. If we have absolute value equals 0, we have one solution, and it's easy to find. Drop the absolute value bars and set 3a plus 7 equal to 0. Subtract 7 from both sides. And we've got 3a equals negative 7. Divide both sides by 3, and we have a equals negative 7/3. E, I've got a fraction to deal with. Absolute value of 3m over 4 plus 2 equals negative 11. But here's the issue. I don't have to do any math here. I've got absolute value equals a negative number. Absolute value is always positive. It can't equal a negative number. So this is simply no solution. Absolute value cannot equal a negative number. It's always positive. Now, F and G are a little bit more complicated. Here's what we've got. We've got absolute value, but we also have some stuff outside of the absolute value, and this is where it gets a little confusing. Before we can say we have two equations, we have to get the absolute value all by itself on one side. So I can't write an equation that says 3 plus this equals 5 and 3 plus this equals negative 5. That will not work. What I have to do is get the absolute value by itself. And I'm going to do that by subtracting 3 on both sides. And so what I've got is the absolute value of 2x plus 2 equals 2. And now I can actually come up with my two equations because I have absolute value equals a positive number, and so I'm going to have two equations. All right, so my two equations are 2x plus 2 equals positive 2, or 2x plus 2 equals negative 2. Those are my two equations, and I'm going to solve both of those. So subtract 2 from both sides. I've got 2x equals 0. Divide both sides by 2. And so I have x equals 0, or here, subtract 2 on both sides. Then I've got 2x equals negative 4. Divide both sides by 2. And I have x equals negative 2. So 0 or negative 2 are my answers. I have a similar situation with G. I have things outside of the absolute value bars. So first thing I'm going to do, I want absolute value all by itself. So I'm going to get rid of the 5 by subtracting both 5 on both sides. Here's the thing you need to be careful of. There is a negative right here. It needs to come down. All right, this negative in front of the absolute value bars is important. It's important in how you handle it. You cannot distribute a negative into absolute value because absolute value gets rid of negatives. All right? What we have to do to get rid of this negative, because we still need absolute value all by itself, is we're going to divide both sides by -1. That's what's going to get rid of that negative. So now these cancel, and my equation here is absolute value of x plus 1 equals +2. And since I have absolute value equals a positive, I will have two solutions. Either x plus 1 equals 2 or x plus 1 equals -2. Subtract 1 on both sides, and I have x equals 1, or subtract 1 on both sides here, and I get x equals -3. All right, let's go to the next page. All right, with h at the top of the page, keep in mind, before you can decide if you're going to have two solutions, one solution, or no solutions, you have to get the absolute value by itself. So here I have absolute value on the right-hand side, and I have a negative here. It doesn't mean no solution. What it means is I've got to get absolute value by itself first. So I need to undo the stuff on this side. The way I'm going to do that is like this. Add 6 to both sides. So I've got 2 equals the absolute value of 3 minus x over 2. I still need absolute value by itself. So multiply both sides by 2. And I'm going to have 4 equals the absolute value of 3 minus x. Now I have absolute value equal to a positive number, so I'm going to have two solutions. They are 3 minus x equals 4, or 3 minus x equals -4. All right, subtract 3 from both sides. Here I'm going to have -x equals 1. Divide both sides by -1, and I'm going to get x equals -1. Here, subtract 3 from both sides, and I get -x equals -7. Divide both sides by -1, and I'm going to get x equals +7. All right, if we look at I, remember, right now we have absolute value with other stuff. So you can't say, oh, this equals 0, we have one solution. No, we have to get absolute value by itself. So we're going to add 2 to both sides to get that absolute value by itself. And we have absolute value of 9x minus 7 equals 2. This is the point, just so you know, to be technical. This is the point. When we decide how many solutions we're going to have, that's when we drop the absolute value bars. We keep the absolute value bars until we decide 2, 1, or no solutions. Here we have absolute value equals a positive. We're going to have 2 solutions. So now I drop the bars, and I have 9x minus 7 equals 2, or 9x minus 7 equals -2. All right, add 7 to both sides. I've got 9x equals 9. Divide both sides by 9, and I have x equals 1. Here, add 7 to both sides. I have 9x equals 5. Divide both sides by 9, and we have x equals 5/9. And very often with these type of problems, you end up with fractions. So don't be surprised by that.